In today's video, we're going to talk about exceptions, why I don't use exceptions, what I use instead, and why you should probably stop using or throwing exceptions in your application as well. My name is Amichai, and in this channel I talk about software architecture, design patterns, best practices, things that you really want to be familiar with if you're a software engineer. So if that sounds interesting and you want to see more videos like this video, then make sure to smash the subscribe button so you don't miss out on future videos as they come out. So off camera, I built this very advanced API. I call it the Movies API, and this API has exactly two endpoints, one to create a movie and one to get a movie. A movie is a very simple object where you have the name of the movie, you have a list of actors, and you have this is hidden property where if it's hidden, then you can't fetch it using the get movie endpoint. So once the service is up and running, then you can go ahead and make a request, and you have a server generated ID for the movie. And then you can go ahead and use it in the get movie endpoint, where you simply go ahead, specify a movie ID, and then you fetch that movie from the database. If you go ahead and specify an ID that doesn't exist, then as expected, you get not found. And if you go ahead and create a movie that is hidden and you try to fetch it by ID, then you get 403 forbidden. So that's the API, pretty simple. Now let's go ahead and talk about why exceptions are evil, and let's start with them being messy. So what do I mean when I say messy? So currently what we have is we're using exceptions for flow control. What that means is that we're using exceptions to control the flow of the application. For example, if we take a look at the movie repository, then we can see that over here where we go ahead and we call get movie, then if the movie is not found, then we throw a not found exception. The reason we're throwing a not found exception is because we want to eventually return 404 to the client. Now, because this is a very small application, then we don't have many exceptions predefined in our app. But as you would expect in applications that use exceptions for flow control, then you don't only have, like over here where we have 6 predefined exceptions that we can use, but you'll have tens of exceptions. Now, of course, the way this folder will look depends on your application. Regardless of the specific exception implementation that you're using to convert the errors to the error response to the user, in the end, when you're using exceptions for flow control, it starts becoming very messy. Why? And for this, I want to show you an example. So we have this hidden movie exception, right? If a movie is hidden, then we want to return forbidden to the user. This is implemented in the movie service, where over here we're trying to fetch the movie, and if it is hidden, then we're throwing a hidden movie exception. Now, if we look at this exception, then we can see that we have an exception that's inheriting from a forbidden exception. And this forbidden exception is inheriting from a service exception. And this service exception also inherits itself from the exception because we want to have the stack trace, etc. So even in our very simple example, we have an exception that's inheriting from another exception that's inheriting from another exception, which is inheriting from the exception base class. Now, what I did about, I think 2 years ago, is I did a search within Microsoft since I was curious to see how other projects scale using exceptions. And I noticed that it wasn't just my project, but almost every project that I looked at that used exceptions for flow control, then you had some folder called either exceptions or errors or something similar, where you have tens of exceptions, and it becomes messy trying to understand, do I need to reuse one of the existing exceptions? Should I create a brand new exception? Should that exception inherit from one of the existing exceptions? It really becomes a mess. Okay, next we have complexity. To understand the complexity case, let me first explain what flow control is. So flow control is the execution path of the application. So if we take a holistic view at the application, then there are various paths that we can go through as the program is being executed. You can use different constructs to control the flow of the application. So for example, you can use if statements, you can use for loops, you can use switch expressions, you can use goto, or you can throw exceptions. There are various mechanisms that you can use to control the flow of the application. What I'm focusing on specifically in this video is what happens when you use exceptions for flow control. Now, the main argument for why yes to use exceptions for flow control is that it reduces complexity. The reason why this is the argument is because of global error handling. So if we take a look at the program CS, then we can see that over here we have what's called global error handling. Global error handling is one place in your application where when exceptions aren't caught somewhere else in the application, then this is like a big try-catch that wraps all the code in your application more or less and it catches it over there. That's why it's called global exception handling. Now, I'm about to show why the complexity is much, much higher using exceptions, but first you need to understand why they're saying that the complexity is lower. So the reason why they're saying that the complexity is lower is because you have the following. And specifically in our application, we have the API, and over here we have the post and the get endpoints. And the API is using the movie service, which in turn is using the movies repository, which is using some client which comes to mock some API client that uses an external service to store the underlying movies, okay? Now, of course, the specifics of this implementation don't really matter. It's more about the idea where you have a component using another component, using another component, using another component, and each one of these components can go ahead and throw a specific exception. Now, the reason why they say that the complexity is lower is because that they say once you throw an exception from one of these components, you go directly to the global error handler, and from there you return a response to the user. So we looked, for example, at the not found exception, then over here we're throwing a not found exception. The global error handler converts this into a not found HTTP status code, and it's returned directly to the user. Now that seems like a very good argument, right? Every time you throw an exception, all you need to do is take a look at the global error handling, see what's happening over there, understand the logic in the global error handling, and you know what will be the response to the client. Now, unfortunately, that naive thought is incorrect, and we'll see now why it doesn't reduce complexity and it actually makes the complexity much higher. So over here, currently what we're doing is we're throwing an exception and that returns to the client. But what happens when we go ahead and we call some component in the movies repository? It throws, let's say, a not found exception. But in this case, we don't want to go specifically to the global error handling and then returning a 404 to the client. Instead, we want to swallow that exception and do something else. So you can imagine, let's say tomorrow morning, we have over here a put endpoint, and the put method goes ahead and uses the movies repository, and it tries to fetch first the item from the movies repository, but it doesn't exist, and this time it doesn't want to return over here 404 to the client, but instead you want to swallow this exception and instead go ahead and create a brand new movie. Now, this is a simple example, and of course it becomes way, way more complex in big production real world applications. And what you end up having is the following. You have various components where each one of these components are throwing exceptions. Sometimes you go directly to the client, but many times you don't go to the client. Instead, what you do is that you jump to another component altogether. And from that component, you jump to another component altogether. And what you end up having is a very unclear execution path where understanding the flow control in your application becomes way more complex. It's not that the flow control is directly to the global error handling and to the user, as we naively talked about before, but instead it can be looked at as a very complex go-to where you're jumping from place to place across your application, and sometimes understanding why when you threw this specific exception over here, then it returned this other response to the client. The flow of control becomes very complex because, of course, you're not just throwing an exception over here, but in each one of these stages, you're either catching that exception, ignoring it, catching that exception, converting it to another exception, putting it nested inside another exception. What's for sure, and you probably experienced this if you worked on such an application, is that the complexity increases when we use exceptions for flow control. Okay, next we have heavy. So here is what the exception looks like. So alongside the small things or potentially small things like the message, we have here an int, we have here some other things that aren't necessarily very significant. We also have the stack trace. The stack trace is potentially very, very big. Also, each one of the exceptions may contain inside another exception where that exception may also have a very large stack trace. You have to take that into account in your application when you're using exceptions for flow control, because if you're throwing millions of exceptions all the time because that's just part of your regular flow of the application, then you're creating these objects on the heap like any other object on your application, which puts pressure on the garbage collector and is not irrelevant in a holistic view of your application's performance. You also need to take into account that for the request, the thrown exception, then that specific request will be slower because throwing exceptions is slower than simply returning back the call stack like in a regular procedural program. Now, where this really starts becoming redundant is in the following two cases which are, in my opinion, the best reasons to avoid using exceptions in your applications, in production, real world applications as of today. The first one being privacy. Now, you may be asking yourself, what does privacy have to do with what we're talking about? Well, privacy is a game changer when it comes to programming today in real world applications. The reason for that is that you can't go ahead and log anything you want to the database. Now, why is that relevant to exceptions? So what we have currently in our application is just nothing because this is a sample application, but what you would actually have if this was a real application is over here you have the exception. You'll want to log some details that have to do with this exception because you want to be able to debug it later, because when an exception happened, then sometimes you want to understand what went wrong. Now, unfortunately, you can't go ahead and log the message in many companies, or if in your company then you're doing it, then you may want to consider not logging the exception message. And that's because you can't log to the database customer content or end user identifiable information, like for example, their email. Now you may think to yourself, okay, all I need to do is just not put customer content or EUII in the message and I can go ahead and log it safely. Well, that's wrong. And a basic example for this is just a serialization exception where you have the exception message saying that there was an invalid character just in position 19, and right next to that, you have the email of the user. So some exceptions you don't control, and these exceptions contain in the exception message customer content, or just let's say call it sensitive information in general, that you can't go ahead and log to the database. Meaning that out of this entire thing, you can't go ahead and log whatever you want. Usually, the only thing that is safe to log, and this may also change depending on the company and the requirements, is the exception type and the stack trace. Now, when you don't have the exception message, then sometimes the exception type and the stack trace just isn't enough to understand what went wrong. A simple example for when the message is required is that various auth-related exceptions. For example, you have some specific claim in the token that is missing or something like that. And without the exception message, then you really don't have what to do. Now, what you could do is you could put here specific logic per exception type, and that's what many applications do. But you need to take into account that when you're using exceptions for flow control, then this spot over here becomes your God place for handling exceptions in your application. And this becomes very complex when you have various specific rules for specific types of exceptions. Especially if you don't take the approach that I took over here, then you're going to have some God switch expression or statement where you're trying to convert the specific exception that was thrown to the appropriate error. Now, the stack trace is very useful and it can give you a lot of details when you're trying to debug what happened, but usually, what you use are various other logs in the rest of the application. What you would actually have if this wasn't a demo application is this would be in some variable, and then you would check if the movie is null. You would also have over here the logger, and over here you would go ahead and log whatever details that you need that can help you debug when this case happens. And over here, you'll also have some other metadata being logged to the database, like the service version, the date and time, and so on and so on, things that you need to debug what went wrong. And the stack trace many times doesn't play such a huge role, which means that this entire object that we're creating and throwing all over the place won't be used most of the times for debugging. From my experience, most of the times where the stack trace has any significance is when the exception was thrown not by my code. Meaning I'm using some library, something in the .NET framework through an exception. I can use the exception type that was thrown with a few other methods from the stack trace to understand what is the root cause. When my code throws an exception, then I know the call stack, or I don't need to look at the stack trace to know the call stack and understand what's happening because I have logs everywhere throughout my application, which give me a wider context than only the stack trace. Last but not least, you have monitoring. So any real-world application that serves users should be monitored. What do we mean by that? So if we're looking, for example, at the global error handling that we have over here, then simply logging details to the database and returning details to the client isn't enough because if some exception is happening in a very high percentage, then you'll likely want to be woken up in the middle of the night about it and know that something's going on. That's why you'll usually have over here also some metrics being sent. So your service as a whole in various places across your application will send data all the time to some third party, which will take all that data and compute it, and you'll write various logic, and you'll have alerts being sent to you when specific scenarios happen. For example, the latency is 3 times as high as usual, or this exception is happening in a very high rate. Some external service is returning an unexpected HTTP status code. Each one of the alerts will have some custom predefined logic that you wrote down, so you'll be alerted when something goes wrong. Now, what often happens with time is that, let's say you're now the OCE or DRI, whatever you call it, the person who's in charge to wake up in the middle of the night when something goes wrong. So you wake up and you take a look at the error that you got, and you're trying to understand and debug what went wrong, and then you see that the exception that was thrown is actually an expected scenario that's supposed to happen. So you go to the monitor and you simply specify over there, you exclude that specific exception type, and you know that that specific exception type is actually okay and it's not exceptional. The next day you wake up again in the middle of the night because an alert was raised, and you see that it comes down to just there wasn't a lot of traffic. So because there wasn't a lot of traffic and an exception was thrown, then this was a high percentage of the overall traffic, and that's why it passed your specifically defined threshold. So usually what you do is you go ahead and you add that I want this alert to be raised only when there's more than, let's say, 100 exceptions. The more rules that you have of this type make your application less sensitive to actual errors that may occur, and you may not notice them ever because it doesn't pass the specific threshold that you kept increasing with time, and you may be missing real failures that your users are experiencing, but they're just not enough to raise an alert. And the bottom line over here, and this has to do with some of the other points as well, is that we're abusing the exception construct, this flow control construct, we're abusing it for non-exceptional situations. If all the exceptions were truly exceptional, then we wouldn't be adding so many rules in our monitors to exclude this actually is an expected exception, which contradicts the entire point of an exception. Now, let's imagine that you're sitting at home and you're somehow convinced by my amazing arguments, which I think you should be because there's a reason why I'm talking about this passionately. So let's say that you're convinced. What is the alternative to using exceptions? Well, that's actually pretty simple, and that is the result pattern. The result pattern is actually a very simple idea in which you return an object that can be in one of two states, either success or failure. So for example, if we take a look at the movies repository again, and we have where we're throwing this not found exception, instead of returning a movie over here, we'll return the result object. This object will either be in a success state and will contain the movie, or it will be in an error state and then it'll have the underlying error or errors that occurred. Now you can go ahead and create this result class and have it be like a discriminated union between the value or the error, or you can go ahead and use a NuGet package for this. Now, there are many NuGet packages that implement the result pattern, but we're going to use my specific favorite NuGet package for implementing the result pattern, which is ErrorOr. So all you need to do to use ErrorOr is, first of all, adding the package, which is simply called ErrorOr. And then you can go ahead and say that you're returning an ErrorOr struct, which over here, as the naming suggests, we're returning either the error or a list of errors or the movie. To use it, all we need to do is the following. Let me get rid of the code over here. And let's say that if the movie is null, then what we want to do is we want to return an error. Now, because there are specific error types that exist in any application regarding the domain or framework or technology that you're using, then ErrorOr has specific extension methods that you can use to create errors. So you have errors like, for example, not found, right? So currently something is not found. This isn't coupled directly to the HTTP not found, but it's generally something that's not found. So that's what we're going to use now. And over here, let's also add a human readable description. And let's say over here, movie not found and same error like we had before. And finally, if everything is okay, then we can go ahead and return the movie. Same thing like before. Now, you're probably looking at this and thinking to yourself, this component is simple, so all we need to do is go ahead and return the error or the movie. But in the component calling of this component, then it's not so simple, because over here in the movie service, we can't simply go ahead and access the isHidden property because this is no longer the movie, but it's an error or the movie, which means that over here we have the get movie result, and we need to go ahead and check if this is an error first. So if this is an error, then in our case, we simply want to go ahead and return the errors back to the caller, which means that we also need to update this to now be ErrorOr movie. And then over here, if we want to access the movie, then we need to go ahead and say get movie result dot value dot is hidden, and then finally return get movie dot value. But it doesn't end there. We also need to go to the component calling this component and update that as well. Now you may be looking at this and asking yourself, in what world is this considered simpler, less complex than the other approach? Now I'll list the reasons, but I first want to say the disclaimer that I'm the author of the ErrorOr library, so I think I forgot to say that beforehand when I was being all sarcastic. Okay, so the reasons why using the result pattern is better than using exceptions for flow control is the following. Number one, when you're using the result pattern, then any component that may fail will return an error or the result. Meaning that as the caller of the next component, so over here, for example, we're calling get movie, as the caller, we know that we're getting either an error or the movie, which means that we need to be explicit and we need to think about the error flow as well. Over here, we have the chance to say, in case an error occurs, do we want to go ahead and log some details to the database? So for example, we may have over here some specific piece of information that we may not have down the road, and we know that it's compliant and it's okay to log. So over here, we have this chance, we can be explicit. And also developers, when they use the result pattern, then it becomes a healthy habit without explicitly teaching the team that this is how it needs to be. Because when you're doing a code review, then you can say, okay, over here, perhaps there's something specific that I want to do in the error flow. And the next case, which I think is a better case, is that over here we have this hidden movie exception. This exception is a bit different than the other exceptions because this has to do with business logic. So over here, we're not just throwing something because a resource was not found, but this is our specific application's decision to not return hidden movies. So over here, if we're using the result pattern, then instead of this, we can go ahead and say error dot. So one option is to write over here forbidden and put whatever the details like we did before. But a nicer approach, in my opinion, is to go ahead and create over here a new folder and call this something like errors. And over here, we can create something like movie errors. And over here, we can create our hidden movie error. And we can give this maybe something more meaningful, like for example, cannot fetch hidden movie. And we can have this be whatever we want. We can have this be forbidden or custom and put our custom business or domain exception that we want. And now something nice that we have in this error is also a unique code. So currently what we can do is we can say movie and give it something unique that we know that represents this specific business failure that occurred, with also a human readable description. Let's say a hidden movie cannot be fetched. Once you have this, then you can go back to the movie service, and over here, instead of throwing this exception, then you can say over here movie errors, and you can return this specific error. And you have this error represented in a singular place in a well-organized manner, because as this grows, then you'll have more and more errors over here, and all your movie-related business errors will be in one place where it's also easy to look at, and it's also human readable, and it has a specific representation within your system because it has a unique code. Now, before we finish this video, I just want to say that ErrorOr just hit 1 million downloads, which is pretty insane. So thank you for everyone who's been using the package, helping me out with issues or with pull requests. I appreciate it a lot. It couldn't have happened without you. And also, I just released ErrorOr 2.0, which contains many very useful functional extension methods, which we'll look into in depth in the next video, which will be called Introducing ErrorOr 2.0 or something like that. And we'll see how we can use all these various extension methods to make the code way more concise and, in my opinion, funner to write. If you're currently using exceptions for flow control in your application, then I'm very curious to hear if this was convincing to stop using exceptions. And on the other hand, if you're using the result pattern and you tried both experiences, then I'm curious to hear what was your experience and if it works better for you. So that's it for this video. I hope you enjoyed it and you learned something new. Make sure to smash the like button, smash the subscribe button, and I'll see you in the next one.